Hello everyone, I'm Farah and I'll be presenting the introduction for our group team project titled Analysis of College Student Placement Factors. So, in reality, securing a job after graduation is becoming increasingly complex. While a degree once considered as a guaranteed ticket to employment, but today's job market demands so much more. So, the project basically focuses on understanding the key factors that influence job placement success among college students. So we are using a dataset from Kaggle and we basically analyze 10,000 of student records. So the purpose of this study is to support both student and also educational institution with data-driven insight that can guide them academically and personal development decision. So by identifying this pattern in historical placement data, we aim to help students make informed choices and also at the same time assist institution in designing programs that align with industry expectation. So the scope of our analysis involve cleaning and transforming the dataset to ensure the accuracy followed by visual exploration. So the key outcome would be whether it shows CGPA is a strong predictor for job placement, whether internship experience significantly enhance the employability, and also whether soft skills like communication and leadership are actually crucial. So this insight highlight the importance of a balanced student profile that combines academic excellence, practical exposure, and also interpersonal
So
skill.
next, I will present about our problem description. First is our problem statement. In the current job market, many graduates encounter challenges in securing employment after completing their studies. Despite earning academic qualification, a significant proportion of study remain unemployed and underemployed, suggesting that academic performance alone may not determine the job readiness. So, what is our objective for this project is this project aim to identify and analyze the key features that influence job placement outcome using dataset that contain 10,000 student records from 100 college. What visualization we're gonna do is first is bar chart, second is box plot, third is heat map, fourth is stack bar chart. Tools we're gonna use is we are going to use Python for the primary language, Pandas, Seaborn for the Matplotlib for the library, and Streamlit for our visualization.
Hello, I am Anis and I'll be presenting about data description. So the data set that we are exploring is the College Student Placement Factors dataset. It is a large scale, open source and also a synthetic data set that is available on Kaggle and created by Sahil Islam. And the dataset focuses on various factors that affecting students' chances of securing a job placement after graduation. And this dataset contains about 10,000 rows and 10 columns and is stored in a CSV file format. And each row represents each student's academic and extracurricular details as well as their placement status after graduation. And most of the data types for each columns are numerical except for college ID, internship experience, and also placement status. Moving on to the dataset schema, this is basically a visual representation in which we can see how the data is organized into multiple related tables. So the schema represents four key tables, which the first one is the student table that store student-specific data including IQ and placement status. The next table is the academic record table that contains student academic performance data such as previous semester results and CGPA. The third one is the experience table that stores information about internship experiences and the number of projects that completed by a student. And lastly, the soft skills table that include data on extracurricular scores and communication skills. So each of these tables is connected through the college ID attribute, which is the unique ID for each college. And this attribute is very crucial for organizing data properly by individual college and student.
Hello, my name is Alia and I will be presenting the data preparation. First, to prepare the data for the visualizations, we check if the data set contains missing values. By using the pandas function, df.info, the overview of the data frame structure is printed to the console. Based on the output, we can see that this data set contains no missing values as the non-null count shows that there are 10,000 non-null for this data set. This checking is to avoid inaccuracy and bias analysis, and since there are no missing values, imputation step is also not required. Moving on to the next step in data preparation, besides checking the missing values, we also check for duplicate rows. We use panda function to count if there are duplicate rows in the data set. Since the function returns 0, it indicates that there are no duplicate values as well in the data set. This step is to ensure data integrity, and since there are no duplication, data removal step is not needed. Next, to make the correlation and comparison across variables easier, we also converted categorical variables to binary. The categorical variables in this dataset is the internship experience and placement columns. Since the data is based on the yes and no, it is mapped as 1 for yes and 0 for no. This step is also to simplify the analysis and visualizations.
For the last step in data preparation, we identify irrelevant or outlier values. There are some of the CGPA values that exceed 10.0. Most academic grading systems in the world do not have the CGPA maximum that exceeds 10.0. So we handle the invalid CGPA values by replacing them with mean CGPA values. We then remove the invalid CGPA values as it will reduce the dataset entries because the invalid CGPA values are about 249 entries. We also then replace them with 10.0, the maximum value of CGPA, because this will introduce artificial bias. By replacing the invalid values with mean, we can retain all the student records and preserve the dataset. Mean also represent the overall average performance.
Our first visualization and solution is first bar chart. So the bar chart is the data visualization tools that display categorical data with rectangular bars representing the frequency of each category. According to Atlassian, bar charts are especially effective for making comparison across discrete group by using line or represent value. This bar chart is used to display the distribution of job placement outcomes among students categorized into two groups. Those who were successfully placed in a job after graduation is plot as 1, and those who were not get the payments plot as 0. So our finding is find out that majority of the students are not placed. The bar chart revealed that a large portion of students, approximately 83%, were not placed after graduation. This overwhelming majority points to significant employability gaps among student graduates. Our second insight is only a small fraction secure a job. Only about 70% of students were successfully placed. This low percentage suggests that job placement is not guaranteed even after completing a degree, and other factors must be influencing these outcomes.
For the second solution, we choose a box plot. The box plot is used in this project to visually compare the CGPA distributions between students who were placed in jobs and those who were not. It provides a clear summary of the data's distribution using key statistics like the median, quartiles, and potential outliers. From the visualization, it is evident that placed students generally have higher CGPAs, with most of them scoring above 8.0, indicating a strong link between academic performance and employability. Additionally, the distribution of CGPA among placed students is narrower, suggesting that those who get placed tend to perform consistently well in academics. On the other hand, unplaced students show a wider spread in their CGPA, including lower scores, which reflects more variation in academic performance. The plot supports the idea that strong academic results are a significant factor in placement success. However, since not all high performing students were placed, this also suggests that other elements such as internship experience, communication skills, or extracurricular involvement may play an important role in increasing employability.
I will now present the third solutions and findings, which is the correlation heat map analysis. So the correlation heat map is a data visualization that helps to display relationships between numerical variables using color gradients. And according to Bobbitt, it has Pearson correlation coefficients that ranging from -1 to +1 and are used to identify how strongly different factors are related. So key insights from the heat map is the first one is the relationship between CGPA and previous semester result. So these two features shows a very strong positive correlation of 0.95, and this is expected as CGPA aggregates the results from all semesters, meaning that students with consistent good performance in individual semesters will tend to have a high CGPA. The next insight is the placement and other factors. So several factors such as communication skills, previous semester results, CGPA, and also IQ shows moderate positive correlations with the placement. These factors contribute to placement success, but however, they do not really dominate it. This means that in order to secure placement, a student must excel in all of these factors, as each of these contributes significantly to the overall success of placement. And the next one is the project completed has minimal influence. So the projects completed feature shows a low correlation of 0.22 with placement. While completing projects can be valuable, it does not strongly affect academic or placement outcomes. So this highlights that this factor is more practical and skill-based. And lastly, IQ has no link with academic scores. So surprisingly, IQ shows a weak negative correlation of negative 0.01 with CGPA, and this challenges the common assumption that a higher IQ guarantees better academic performance.
For our fourth solution and findings, we have stack bar chart. Stack bar charts helps when we want to compare parts for crossing the whole categories that will make them ideal as the categorical data analysis. In this chart, we also provide the feature of drop-down list where they can choose either to display all students, only those who were placed, or even only those who were not placed. So, students the findings that we have is students with the internship experience where the internship equal to 0. This group has the largest number of students among all. Visually, the height of the light blue segment is much more greater than the dark blue segment. This indicates that the most students with the internship do not get job placement. For students with internship experience, meaning internship equal to 1, this group has less students compared to those with no internship. But as we seen in the charts, we can see the dark blue segment is much more higher than dark blue segment in the no internship group. So this indicates that students with internship experience were more likely to get placement in jobs. So, we conclude that internship experience positively affects placement because there are few students that had internship experience, but those who have it showed a higher placement rate than those who do not. And this suggests that internship participation will improve the students' employability. People with no internship experience may face a higher challenge in securing a job after graduation.
To conclude, this project basically successfully identify and analyze the critical factors that contribute to placement success among college students. While academic performance, especially CGPA, plays a very crucial role, the study reveals that it must be complemented with a real-world experience and also strong interpersonal skills. So internship exposure prepares students for the workforce, while soft skills such as communication and leadership are highly valuable by employers. This finding basically suggests that students who have both technical and personal competencies are better positioned for a successful placement. So, moreover, the project emphasizes the importance of data integrity. So, by ensuring the dataset was clean and complete, we were able to generate a reliable and meaningful insight. So this study also contributes to a broader understanding of graduate employability and offer a practical framework for improving a placement outcome. So by aligning the educational efforts and also with market expectation, student and institution can work together to help ungap between academic achievement and also career readiness.